Hi, this is Paul from Foresight Tech. In this video, we are going to deal with the initial value for linear model. Let's see the outline. First, I will introduce the formula for finding the initial value. Then we will practice two questions together about how to use the formula. Let's see the material. Here is the initial value. Let me first highlight what the question. Okay, and the question is here in this equation. And this equation, of course, is the explicit formula, right? And if we know Pn, if we know D, if we know N, what we don't know is P0, which means what? We need to find the initial value, right? Okay, and what is the result? Of course, is here. Easy to resolve that equation. So we get this is the formula for us to find the initial value. Let me draw a graph. Okay, so the graph will help us to understand the question. Let me draw this kind of a graph. If this is the time n, and if this is Pn, and of course this is 0, and if here is P0, the initial, and then I choose a model, it goes up, okay, it's a linear growth model. And then look, we have this point, Pn is where? Pn this time should be here, right? This is n, this is Pn. We know this point. You say it's the future. Or usually we call this type of question, we say this point is the current value. So we need to go back to find the what? Go back to find the value in the older time. You can say it's the initial. Okay, no problem. And then what do we need? What is P0 equals? This point we don't know. And here are the questions. What do we need? We need the Pn, we need the N, we need the D, right? So let me see how to solve this equation. Okay. Solve this equation is easy. We just use the old equation, which is Pn equals P0 plus Dn, right? And what we don't know is P0. Of course, we can do this simple way: minus Dn the right, minus Dn to the left, and therefore the right we can cancel. So what do we get? We get the left is Pm minus D times M. The right is P0. Is this the formula? Yes. So this exactly is the formula we need to find the initial value. One more comment to this formula. Okay. One more. Just look at it. This is the formula to find the P0, right? If I change the form, we have another understand. If I change the form to this, do you think they are the same? For P0 equals Pm plus negative D times N. Are they the same? Yes. Why? Because a minus number, it means a plus a negative number, right? And if we look at this, okay, this is a linear decay model, but we have to look backwards. Okay. And let me draw it. And this is a linear decay. If we look backwards, what does it mean? If we see this is the initial, Pn is the initial, we will look backwards to this way. Can you see? Okay. And from Pn, look back to P0. Therefore, the model what? Goes down, right? What is the slope? Is negative D. That doesn't make sense. Which means this find the initial value. If we look backwards, is still going to find the future value. But the model is a decay model. And this is the formula now. Let's practice two questions. Here is the first question. And I opened a savings account 5 years ago without the interest earned and added 4,000 each year. Now I have 30,000 in the account. How much did I deposit when I open the account? Can you see this is a linear model to find the initial value? Why? Okay, a linear model because each year I added the same number of money, right? So 4,000. So the common difference, you can say this is the common difference. Okay, and then I have 30,000 in the counter right now. Okay, so what are we going to do? We're going to find the money, okay, the original deposit, which means we have to look backwards, right, to find the value in the older time. See, and this is exactly the initial value. Why? Let me draw a graph so you can understand. We do this way. If I draw this simple graph, if this is the time, okay, and now the question, we are here right now. This is the time now. Okay, so this is the time, or you say it's n. What we don't do is the open. At this time, we open the account. Okay, we say this the time we open the account, and now see, and our questions we don't know the value here. Let me set up this is P0. So P0 is what we don't know, but we do know what is the value here. So how to find the value? Of course, this time, this is the future value. So the value right now, so we call it the future value. Why? Because relative to the initial. So this is the future time, right? So we call the future value. What is that? How long the time passed? Can you see? N is 5 years past, because these questions we know. So this point should be P5. Do we know P5? Yes, right? And this question show we go back to find out what is P0. We know the future. What we don't know is the initial. And of course, we know everything else. N equals 5. What is D? Let me see. What is D? Okay, so here is D, right? Common difference. Okay, easy to see this is D. And what this value, this is Pn, the future, which is P5, right? And now all we need to do is just solve the formula. Can we see? So let me write down the formula first. Is P0, right? Equals Pn minus n times D. Do you remember this is the formula we need? Now plug everything into the formula. So we have this P0 equals Pn, which is P5, right? N is 5 minus 5 times D. Okay, do calculation. P5, which is the value current, right? The current time, which is 30,000 minus 5 times D. What's D? D is 4,000. See, easy to do calculation. What do we have? We have 30,000 minus 5. No, 5 times 4,000, which is 20,000, right? Okay, so the value is 10,000. Easy to find. Okay, 10,000, which is C, right? C is the answer. That's the value when we open. That's the initial deposit, and 5 years ago. And let's going to see one more question. Here is the second question. A town's population has been growing linearly, which means this is a linear model, right? A linear growth model. In 2019, the population has reached 100,000, and the population has been growing by 1,200 each year, which means the common difference, right? What's the population in 2012? And we see 2012 should be is an older time compared to 2019, right? So if we set up the value, the population in 2012, and that as the initial value, and then 2019 should be the future value compared to 2012. Therefore, this is a initial value problem. Okay, let me draw a graph so we can understand the timeline like this. So we're going to draw, and you know this question is similar as the last question, right? If here is the time. Now what do we have? We have one time point, another time point. So if I set up this is 2012, so this time should done the 19, right? And of course, this is the old time. So we set up this is the old time as the initial, which means P0. See, that's the question. And now this time point should be the future value compared to 2012, right? And what is the time past? Of course, 2012 to 2019, the time is 7 years, right? And you use 2019 minus 2012, we get n equals 7. And then, therefore, 2019 should be P7. This should be the future value compared to 2012. See, we know the future value. We don't know the initial. So how to find? Let me copy the formula. And the formula gives us is P0 equals Pn minus n times d. Okay, so that's the formula we need. In our questions, specific n equals 7. Therefore, P0 equals P7 minus 7 times d, right? Of course, we need to find what is P7. Can you see? And this number is P7, right? P7, which is the population in 2019. What is D? Common difference here. Can you see? So this is just D. Okay, therefore we have everything ready. So I just plug in. So P7 is 100,000 minus 7 times 1200, and then we do the calculation. 100,000 minus 8,400, right? You do the subtraction, we get 91,600. Can you see this is the answer? Do we have 1? Yes, A is the answer, right? Okay, that's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget you are very welcome to subscribe to my channel for more videos. In the next video, let's see. We are going to deal with the timer for linear model. Hope to see you there. Thank you. Have a nice day. Bye.